In a universe of seemingly infinite scale and countless wonders, it's curious that the one thing we're desperate to find is something as ordinary as ourselves. To discover that we are not alone. Just 40 light-years away in the constellation of Aquarius lies a tiny, dim star called TRAPPIST-1. It's cold and ancient, and yet it hosts something extraordinary. Not one, but 7 Earth-sized planets. It's as if nature itself set up an experiment. Can life exist around a star like this? And at the heart of this cosmic laboratory is a world that still holds promise, TRAPPIST-1e. And now, thanks to data from the James Webb Space Telescope, we may finally have a glimpse into its world. What it found is astonishing, pushing the telescope to its absolute limits. This isn't just another rock in space. The data coming back from TRAPPIST-1e could be the first true sign of a habitable world beyond our solar system. That is, if the very star that offers the chance of life hasn't also issued a death sentence. Before we dive into what Webb found, let's set the scene. The TRAPPIST-1 system, fully revealed back in 2017, is extraordinary. It's a compact family of planets all orbiting an ultra-cool red dwarf. This star is only a little larger than Jupiter and about 1,800 times less luminous than our Sun. A difference that's like comparing a single candle to a football stadium floodlight. For any of these planets to receive enough energy to support life, their orbits need to be much, much closer than we are to our Sun. And in the TRAPPIST-1 system, they certainly are. All 7 planets orbit their star faster than Mercury orbits ours, with TRAPPIST-1e completing a full year in just 6 Earth days. This has a strange consequence. The planets are likely tidally locked, with one side trapped in eternal daylight and the other in a never-ending night. Just like we only ever see one side of our own moon. It's a truly alien setup, but it's this strangeness that makes it a perfect laboratory for the James Webb Space Telescope. 3 of these planets, E, F, and G, orbit right in the middle of the predicted habitable zone. But TRAPPIST-1e is special. Its size, mass, and density are remarkably similar to Earth's, and it receives about 2/3 of the energy that we do from our Sun. But it takes more than light for life to thrive. TRAPPIST-1e would almost certainly need an atmosphere, so that's exactly what scientists have been looking for. To answer that question, astronomers turned to Webb's powerful eye. One group, the Deep Reconnaissance of Exoplanet Atmospheres team, that's right, the DREAMS team, wanted to set James Webb's sights on the TRAPPIST-1 system as soon as they could. They used a technique called transmission spectroscopy. As an exoplanet passes in front of its star, James Webb not only measures the drop in brightness, but also how the spectrum of starlight changes as it filters through the planet's atmosphere. The telescope's near-infrared spectrograph, or NIRSPEC for short, measures which wavelengths of light are absorbed. Different gases leave behind a unique chemical fingerprint, like a barcode. By reading this barcode, we can work out if there is an atmosphere, and, if so, determine which gases are present. And it's been particularly easy to get a read at TRAPPIST-1. In fact, the data we have is 10 times more sensitive than what we have on any other similar system. Why? Counterintuitively, it's because the star is relatively dim. The light a planet obscures causes a bigger relative drop in the star's apparent brightness, and a bigger difference is easier to measure. So far, the DREAMS team has seen 4 TRAPPIST-1e transits with James Webb. But what did they find? Well, we can start by discounting a few possibilities. We now know that TRAPPIST-1e does not have a primordial atmosphere, one a planet is born with. These are usually dominated by light gases like hydrogen, which haven't been detected. They were likely stripped away by the star's radiation long ago. Nor does it seem to have a carbon dioxide-dominant atmosphere like Venus, which is thick and dense. An atmosphere like that of Mars, which is thin and sparse, is also unlikely. Believe it or not, all of this is good news, as it's unlikely that any of these atmospheres could support life as we know it. The easy answers were off the table. Essentially, where scientists expected to see a strong barcode full of dips and wiggles, They instead saw something tantalizingly close to a flat line. The signal was either incredibly weak or simply not there. The truth about TRAPPIST-1e was going to be far more complicated and far more interesting. This is where the story splits into two very different paths. One leads to a dead world, and the other to a completely new vision of what a habitable planet can be. Before we explore that incredible dichotomy, if you're enjoying this journey to the frontiers of astronomy, take a moment to subscribe and hit the bell icon. You'll join us as we unpack the biggest discoveries from across the cosmos. So what does a nearly flat line from the most advanced telescope in human history actually mean? It leaves us with two primary and dramatically different possibilities. The first is the death sentence scenario. The simplest explanation is that there is no atmosphere for the starlight to filter through. It could mean TRAPPIST-1e is a bare, airless rock. This is a very real possibility. Red dwarf stars like TRAPPIST-1 are notoriously violent, especially in their youth, lashing their inner planets with powerful flares. We've already seen what this can do. jwst observations of the two innermost planets, TRAPPIST-1b and 1c, show they are barren worlds, their atmospheres completely stripped away. It's entirely possible that TRAPPIST-1e, despite being a bit farther out, suffered the same fate. But there is another, more hopeful interpretation. An equally valid fit for the data is a world with a secondary atmosphere, one made of heavier gases that are harder for a star to strip away. Well, here's the big one. There could be an Earth-like atmosphere, one dominated by nitrogen. The data also weakly hints at something strange: methane. This is the exo-Titan scenario, where TRAPPIST-1e might resemble a warmer version of Saturn's largest moon. This is a bizarre and exciting possibility. On Earth, methane is a greenhouse gas, but around a cool red star, it can act as an anti-greenhouse gas, cooling the surface. This would completely rewrite our understanding of a planet's climate. However, that might be too much to ask. It's important to be cautious. The hint of methane is extremely tentative and could just be noise from the very active star itself. Still, the possibility of a thin, nitrogen-rich atmosphere, much like our own, remains. Such an atmosphere might be just enough to support a global ocean by circulating heat on this tidally locked world. So, where does this leave us? We are standing at a scientific crossroads. jwst has ruled out the easy answers, leaving two leading possibilities: a dead, airless rock, or a world with a strange secondary atmosphere we have no parallel for. I know, it might sound a little hopeless, but this ambiguity is not a failure. It is the scientific process in action. The fact we are able to measure the light absorbed by a potential sliver of atmosphere on a world 40 light-years away is pretty incredible. And scientists haven't given up hope. In fact, they are doubling down. The DREAMS team has scheduled up to 15 additional observations of TRAPPIST-1e. They plan to use an innovative technique, observing the known airless planet TRAPPIST-1b just before or after E. By doing this, they can create a clean template of the star's light, allowing them to more effectively subtract its noise and isolate the faint signal from planet E's atmosphere. These upcoming observations could be a key step in the search for life. The question of TRAPPIST-1e has transformed. It's no longer just, is there an atmosphere? Now it's a far more profound question. Have we found a dead rock? A warning that life around red dwarfs is impossible? Or are we seeing the first hints of a completely new class of habitable world? Perhaps TRAPPIST-1e will turn out to have a unique, inhospitable atmosphere, or perhaps one that could theoretically support life. Or maybe, just maybe, we'll find one just like home. Whatever the atmosphere turns out to be, I find it hard to shake the feeling that the discovery of extraterrestrial life feels inevitable. The only question is, when?